topic is ketolysis. So in ketolysis, the breakdown of ketone bodies which are formed by ketogenesis. So the ketone bodies which were formed by ketogenesis are broken down in the heart. These ketone bodies are sent to the heart renal cortex. So there they are broken down in the mitochondria to form acetyl CoA, which enters the TCA cycle to provide energy. So the site for ketolysis is heart muscle renal cortex, because they prefer ketone bodies than glucose. It also ketone bodies are also utilized in skeletal muscles and brain. When glucose is not available, then all this reaction occurs in the mitochondria. So the reaction is the beta hydroxybutyrate. As we know, it is formed in the mitochondria in ketogenesis. So it is one of the ketone bodies formed, beta hydroxybutyrate. So first dehydrogenase acts, and we know when dehydrogenase enzyme acts, it acts the electron receiver is usually FAD or NAD. Here it is NAD plus. So beta hydroxybutyrate is undergoes dehydrogenation to form acetoacetate. In the presence of thiophorase, acetoacetate is converted to acetoacetyl CoA. This thiophorase enzyme, it is absent in the liver. Liver lacks the enzyme thiophorase, so liver cannot utilize ketone bodies. So this is the reason why liver cannot utilize the ketone bodies which are formed, because ketone bodies were formed in the liver and they were transported to the extrahepatic tissues because they couldn't be utilized in the liver. So liver can't utilize the ketone bodies because it lacks thiophorase. So this reaction is occurring in renal cortex and heart muscle. So they have the enzyme thiophorase. So thiophorase breaks down acetoacetate to form acetoacetyl CoA. So thiophorase converts acetoacetate to acetoacetyl CoA. Here we use succinyl CoA, which releases succinate. So the CoA is here. So acetoacetate becomes acetoacetyl CoA. So basically only one CoA is added from succinyl CoA, that we can remember. Then this thiolase, we are using thiolase enzyme for conversion of acetoacetyl CoA to 2-acetyl CoA. This acetyl CoA enters the TCA cycle to provide energy later. So this is the reaction. Now what happens is this is significant because it provides energy during starvation for extrahepatic tissues. So the normal level of ketone bodies is 1 milligram per dl in serum blood and 100 milligrams per day in urine is normal. So if it increases above 1 milligram per dl, there will be ketonemia, and if the amount of ketone bodies excreted in urine increases above 100, here it's above 100, it causes ketonuria, ketone in the urine. So the clinical in this is in prolonged starvation or diabetes, uncontrolled diabetes, high rate of because of this We know that how the why this fatty oxidation occurs, because of lipolysis. Lipolysis occurs because of starvation. So high rate of fatty acid oxidation occurs in starvation, if glucose is not enough. So because of increased fatty acid oxidation, more acetyl CoA is formed. This acetyl CoA enters ketogenesis. When more ketogenesis occur, it results in it provides a lot of ketone bodies than the requirement of extrahepatic tissues, exceeds the limit of utilization of extrahepatic tissues. This results in accumulation of ketone bodies in the blood. Because of this results in ketosis. So there are three types. It's three clinical conditions of ketosis, which is ketonemia, ketonuria, acetone breath. So as I said, ketonemia, increased ketone bodies in blood above 1 milligram per dl. Ketonuria, excretion of large amount of ketone bodies in urine, which is above 10 milligrams per day in the urine. Acetone breath means because of increased ketone body acetone, it is excreted through the lungs or expired through the lungs. The ketone is expired or eliminated through the lungs. Then this is what are the three things that occurs in ketosis: ketonemia, ketonuria, and acetone breath. So this occurs, as I said, it occurs in prolonged diabetes mellitus and starvation. In prolonged diabetes mellitus, what happens is why does this occur? Ketosis is that this in diabetes mellitus, due to in diabetes mellitus, gluconeogenesis occurs. They're trying to produce glucose from other products other than carbohydrate. So gluconeogenesis occurs, which will be using oxaloacetates. So this oxaloacetate is reduced. So without this oxaloacetate, acetyl CoA, which is being given by this ketolysis, cannot enter the TCA cycle because there is oxaloacetate deficiency. So what happens is, instead of entering TCA cycle, they go for ketogenesis again. Because of this, ketone bodies are deposited. It's like going again backwards types. The same in starvation. Because of ketogenesis, there is no oxaloacetate, but oxaloacetate is required for TCS, required for without oxaloacetate, acetyl CoA cannot enter TCA cycle. So all the acetyl CoA is going for ketogenesis. Ketone bodies are formed. So there is one more condition. This is an important clinical condition that was very aesthetic. Yeah, so this this ketoacidosis, what happens is, due to increased acetone bodies, which is acetoacetate and beta hydroxybutyrate, all this acetoacetic acid, beta hydroxybutyric acid, they are strong acids. So to buffer the strong acids, we use bicarbonate. It is buffered by bicarbonate. So if all the bicarbonates are used for just these keto acids, so there is due to continuous production of their continued production for this purpose, bicarbonates become deficient. So because of this, there is reduced blood bicarbonates. This causes a decrease in blood pH, resulting in acidic blood, which is acidosis, which occur due to ketones. This is called as ketoacidosis, which can be fatal. So you can diagnose. How can you diagnose if you have ketoacidosis? By just checking in the urine. There are two tests: Rothera's test and Gerhardt's test. These are the diagnostic tests for ketoacidosis, or to check the ketone levels in the urine.